Bismillahirrahmanirrahim. Now coming to the electronic configuration of elements. In order to understand the electronic configuration of element, we must have an idea about the n plus L rule. ये वही point है जो हमने Aufbau principle में भी discuss किया, that electrons are added to energy subshell by the order of increasing energy level. Let us take the example of calcium first in order to understand that what is this n plus L rule. As we know that the atomic number of calcium is 20, let us write its electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6. यहाँ तक हमने complete कर ली electronic configuration for 18 electrons, that is the electronic configuration of argon. Now what about the next two electron? 3p के बाद क्या electron 3d में जाएंगे? Means क्या 3d2 लिखा जाएगा? No. After this 3px, the next shell that comes is 4s. And the correct electronic configuration of calcium is this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, not 3d2. Why? Electron 3d में क्यों नहीं गए, 4s में क्यों गए? This is all because of this n plus L rule. So, the electron will first enter into the orbital which have lower value of n plus L. If n plus L value is same for two orbitals, then the electron will enter into that orbital which have lower value of n. Let's see in this table. That is the calculation for n plus L. Here, this n is the principal quantum number and L is the azimuthal quantum number, and in the last column we have calculated n plus L values. Now if the value of n is 1, sequence में चलेंगे, the value of azimuthal quantum number will be 0, 1 plus 0 will be equal to 1. Let us take another value such as for 3d, n will be 3, L will be equal to 2, and 3 plus 2 will be equal to 5. So what conclusion can be made from this n plus L table? The conclusion is that the electrons are added to the subshell by the order of the increasing energy level. ये हमें energy level के answers मिल रहे हैं. इन energy level के answers के हिसाब से electrons की filling होगी. Which mean as 1s has the lowest energy, सबसे पहले electron 1s में जाएंगे. ये fill हो जाएगा. Then 2s में. Then 2p में. Then 3s, then 3p. Now come to another important point. 3p की एनर्जी है 4, 3d की एनर्जी है 5, whereas 4s की एनर्जी है 4. Means ये दोनों एनर्जीज हमारे पास सेम आ रही हैं. अगर n plus L रूल के अकॉर्डिंग हमारे पास एक ही आंसर आ रहा हो, then the electron will enter into that orbit which have lower value of n. अब हम देखेंगे कि principal quantum number की value कहाँ छोटी है. Here it is 3 and here it is 4. Means पहले 3p और उसके बाद 3d नहीं 4s आया. 4s के बाद next 5, that is 4p. After 4p, we can see that we have again answer 5, and here the principal quantum number is 5. इसीलिए 4p के बाद electron जाएगा 5s में. After 5s, then we have the energy for 5p. So then it's 5p. 5p के लिए भी आंसर 6 है और 6s के लिए भी आंसर 6 है. फिर वही सवाल, they are having the same answer for n plus L value. Then we have to see the principal quantum number. यहाँ principal quantum number 5 है, यहाँ principal quantum number 6 है, इसीलिए पहले 5s, फिर 5p और फिर 6s, क्योंकि यहाँ principal quantum number की वैल्यू ज्यादा है as compared to 5p. After 6s having energy 6, we have these three, 7, 7 and 7 answer. Again, now the competition will be in their principal quantum number 5, 6 and 7. So 5d, then 6p, 7s and so on. So the final conclusion by the n plus L rule is the electrons are filled according to the energy level. Lower value of n plus L, the electron will first enter into that orbit. Now let us discuss the electronic configuration of few elements in order to make our point more and more clear. Let's start with some basic element such as fluorine with an atomic number 9. Simple electronic configuration 1s2, 2s2, 4 इलेक्ट्रॉन होगा यहाँ तक. फिर हम अलग से लिख देंगे पहले 2px, 2py और 2pz को. डीजेनरेट ऑर्बिटल है. पहले बराबर इलेक्ट्रॉन इन तीनों को दिए जाएंगे. 4 इलेक्ट्रॉन यहां तक मुकम्मल हो गए 2s तक. उसके बाद 5, 6, 7 तीनों को एक एक मिल गया. अब इनकी पेयरिंग स्टार्ट हो जाएगी. 8, 9. 2pz में एक अनपेयर्ड इलेक्ट्रॉन है जबकि 2px और 2py में पेयर्ड है. Hence we have completed the electronic configuration for fluorine. Now let me discuss a very important example, that is of chromium with an atomic number 24. As we know that the noble gases such as neon have atomic number 10, completely filled outermost shell. Next one is argon with an atomic number 18, completely filled outermost shell. तो हम लिख देते हैं argon, which means the first 18 electron have the same electronic configuration as that for argon. 18 से आगे हम बात करते हैं. जब हम argon की बात कर रहे हैं तो हमने 1s2, 2s2, 2p6, 3s2, 3p6 तक मुकम्मल कर लिया. 3p से ऑनवर्ड्स हमारे पास है 4s. 4s के बाद d ऑर्बिटल 3d. 5 ओरिएंटेशंस होंगी. 3dxy, 3dyz, 3dxz, 3dx square minus y square and 3dz square. पहले मैंने इन पांचों को लिख दिया डीजेनरेट ऑर्बिटल. अब इलेक्ट्रॉन की डिस्ट्रीब्यूशन करते हैं. आर्गन तक हमें पता है कि हमने 18 इलेक्ट्रॉन्स मुकम्मल कर लिए. लगता यह है कि पहले 2 इलेक्ट्रॉन यहां जाएंगे. 18 के बाद 19, 20, 21, 22, 23, 24 and this will remain vacant. This is a wrong electronic configuration for chromium. Why it is wrong? First, let me write the correct electronic configuration for chromium. First 18 electron, that is of the same electronic configuration, that is of argon. Then 4s, 3dxy, 3dyz, 3dxz, 3dx square minus y square and 3dz square. The correct electronic configuration for chromium is 4s1, not 4s2, and 3dx1, 3dyz1, 3dxz1, 3dx square minus y square and 3dz square में भी 1 इलेक्ट्रॉन. So ऐसा क्यों हुआ कि 4s में 2 इलेक्ट्रॉन नहीं रखे गए, एक ही इलेक्ट्रॉन आया? The reason is subshells. यानी अगर मैं बात कर रही हूं P, D, F, etc. Subshells are more stable when they are half filled or they are completely filled. अगर हम 4s में 2 इलेक्ट्रॉन रखते फॉर क्रोमियम तो हमारे पास 3dz square वेकेंट रहता. यानी the d subshell will not be in a stable form. अगर पॉसिबिलिटी हो कि किसी तरह से सबशेल या तो हाफ फिल्ड हो जाए या कंप्लीटली फिल्ड हो जाए, तो हम उसी हिसाब से इलेक्ट्रॉनिक कॉन्फ़िगरेशन को चेंज कर देते हैं. सो दिस वन इज नॉट द करेक्ट इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ क्रोमियम. दिस वन इज द करेक्ट इलेक्ट्रॉनिक कॉन्फ़िगरेशन जिसमें 4s में 2 नहीं 4s में 1 इलेक्ट्रॉन आया, जिसकी वजह से हमारे पास द 3d सबशेल बिकम्स हाफ फिल्ड, क्योंकि d सबशेल completely filled होती है when it has 10 electron, half filled होती है when it has 5, और हमारे केस में we have 3d 5 electron which is more stabilized as compared to 3d having 4 electron. Another important example which I want to discuss is of copper with an atomic number 29. Now the first 18 electron having same electronic configuration as that for argon. From now onwards we have 4s, then the 3d xy, 3d yz, 3d xz, 3d x square minus y square and 3d z square. पहले मैंने सबशेल्स लिख ली, अब इलेक्ट्रॉन फिल करके दिखा रही हूं. Now the 4s has 1 electron, whereas the 3d, यहां तक argon तक 18 हो गए, this one is 19, 20, 21, 22, 23, 24. पेयर करते हैं अब 25, 26, 27, 28, 29. I hope you got the answer that why it is 4s1 and not 4s2, which will be incorrect. क्योंकि अगर ये 4s2 होता तो यहाँ पे हमारे पास 3dx square में एक इलेक्ट्रॉन रहता, which means d subshell will be 3d9, which is unstable. We can make 3d completely filled, that is 3d10 in this way. So 3d is now completely filled, which is more stable, as we have already mentioned that the subshells are more stable when they are half filled or completely filled. In this way, various other examples can be quoted and their electronic configuration can be written, keeping in mind some of the important rules like the Aufbau principle, Pauli exclusion principle and Hund's rule, and some other points which are mentioned here like the subshells, they are more stable when they are half filled or completely filled.